Hello students, today we will be solving exponential equations when the base is a proper fraction. That means that b is greater than 0 but less than 1. And for those who are not sure what a proper fraction is when the numerator is smaller than the denominator. For example, in here we might have 1 over 2 or 2/3. Okay, that's a proper fraction. It's less than 1, but it's greater than 0. What is not a proper fraction? If we have 3/2 or 8/3, if this is bigger, it can simplify into a mixed number, which is the 3 goes into 8 2 times. 2 times 3 is 6, and then you have 2 left, and you just carry over. If you notice, this is an improper fraction and it becomes a mixed number. These ones, on the contrary, it will always be smaller in the numerator, bigger in the denominator. Before we start, we're going to review some concepts that we learned in the first video of this playlist. Okay, so if you recall, whenever you have a base with a negative exponent, we cannot have a negative exponent, so we're just going to send it to the denominator and put a 1 in the numerator. Okay, so this will become 1 over a to the positive 2 or positive second power. Again, all we do is send it to the denominator and put a 1 on the top. And by sending it to the denominator, negative becomes a positive, but it only changes the negative exponent, and that only affects the exponent. Okay, only the exponent changes to a positive. Okay, what about number 2? In here, when we have the 3 in there, it doesn't have an exponent. The negative 6 belongs to the x, so the 3 has a chiquitito, meaning a teeny tiny 1. It's so tiny that we cannot see it, okay? But that's positive. It doesn't go to the denominator because it's positive, so it stays in the numerator. This goes to the denominator, and so it becomes x to the 6th power. Now it's positive. In here, let's say that we want to make it into a non-fraction, okay? We don't want it as a fraction. So the 6 is going to stay up there where it is, but we don't want this to be a fraction. And this is something that we will need in our lesson. That's why we're doing this. It goes to the numerator, from the denominator to the numerator, but because in here it's positive 7, by bringing it up there, it changes to a negative 7. So notice how the exponent changes its sign when we move it to the opposite side of where it is. Right now in here it is like having a to the negative 2nd power over 1. We're just sending that power to the denominator. By changing it up, because it was positive, then it becomes negative. Okay? Something else that we will need is something that we saw in the previous lesson and on the first lesson of this entire unit. At the end, you will have the entire unit around here, the link for that. Okay, so when we have something like this, remember that what we do is keep the base and multiply the exponents. Okay, keep the base, multiply the exponents. Negative times positive is negative. 9 times 2x is 18x. Now, if we were asked to leave it as a positive exponent, then we would send it to the denominator. But since we need it that way, that's how we're going to leave it, because we need it with a base and one exponent. It doesn't matter if the exponent is positive or negative for now. Okay, so from that lesson, you notice that whenever we have a fraction, and in the denominator we have a power, that means that it came from a negative exponent. If you haven't seen the previous lesson, again, they are all interrelated, so I recommend seeing the previous lesson in that link. I'm going to put it in the description as well. Okay, so in here, what we need to have, in the previous lesson, we learned that we need to have the same base in order to create equations, okay? Equations with the exponents. That's why they're called exponential equations. Also, I want you to notice that we have an 81 in here and we have a base 3 in here. That means that somehow these will be related to each other. And what I want you to start doing is just factoring this one using that smaller base as one of your factors. And we start dividing. 81 divided by 3, that's 27. If you don't know, use your calculator. Divide by 3, and now you get 9, because 3 times 9 is 27. And then for 9 is 3 times 3. I noticed that the 81 is 3 to the 4th power, because you have 3 times 3 times 3 times 3 is 81. So we're going to replace this side with 3 to the 4th power. The other thing that we want to do is to change this into a base 3, not a base 1 over a power of 3. How do we do that? Well, we just saw in the beginning of this lesson that whenever we have a fraction, 1 over 3 to the 2nd power, we can move that up to the numerator, and it becomes 1 times 3 to the, because we're moving it to the numerator, it becomes a negative 3. I mean a negative 2. Or if you think about it, 3 to the negative 2nd power, oh, we send it to the denominator to make it positive and just put a 1 on top, right? So these are exactly the same. What are we going to do? We're going to replace this base with 3 to the negative 2nd power. So 3 to the negative 2nd power is just replacing this part. We put it between parentheses and bring down what we already have in there. In the next step, we keep the base, and what do we do with the exponents? It's a power raised to another power. This is a power raised to another power. And so that's when we multiply the exponents. Negative times positive is negative. 2 times 2x is 4x. Bring this down. And from the previous lesson, if you recall, once you have the same base, then you can form an equation with the exponents. So negative 4x equals 4. If we're multiplying, the opposite of multiplication is division. Remember that in division and multiplication, we bring the sign with us. So negative 4x divided by negative 4 is positive x. Positive 4 divided by negative 4 is negative 1. So the answer or value of x is negative 1. Now, if you recall, we can create a checkup test, but it cannot be done with this one because they have different bases. We can do the checkup with the second step. And so we have 3 to the power of negative 2, all raised to the 2 times x, but we already know that x is negative 1, equals 3 to the 4th power. So in here we multiply this part, so it's 3 to the negative 2nd power. 2 times negative 1 is negative 2. And then we multiply, because it's a power raised to another power, we multiply the exponents, keep the base. Negative times negative is positive. 2 times 2 is 4. And we see that it is equal to 3 to the 4th power, so we say check. Okay, let's go to number 2. And here we have 4 to the power of x minus 6 equals 1 over 256. But this bigger number in the denominator compared to this, the same as this base, okay? So the first thing we want to do is do the factorization, whoops, not prime factorization, by using this as our factors. Okay, so we need 4. 4 times what number equals 256? We'll just divide 256 divided by 4. Oh, we get 64. Then again, we use the same. We have to use that same base, okay? 4 times what number, or 64 divided by 4 equals what number? 16, because 4 times 16 is 64. And then 16 is 4 times 4. We always have to use the same base, the smaller base of the two numbers, okay? So 256 is the same as 4 to the 1, 2, 3, 4 of them. So we have 4 to the fourth power, okay? Because the 256 is in the denominator, we're going to rewrite it as 4 to the fourth power in the denominator. And we're not changing anything, we're just replacing equals with equals, okay? This is the same as this one because this is also 256. This side, we just bring it down the same way it is. And we still don't have what we need. First, we need to make sure that this is in the numerator to be able to create the equation. Again, if it's in the denominator and we're bringing it up, the sign will change. Because it's positive, it will become negative. So 4 to the negative fourth power, okay? By bringing it to the numerator, it becomes negative. It's the same as having 4 to the negative fourth power. When it's negative, we send it to the denominator to make it positive, but we put 1 on the numerator. See? This is exactly the same as this one, so they are equivalent to each other. This we just bring down. Now, because we have the same base, now we can create an exponential equation. So x minus 6 equals negative 4. If we're subtracting 6, the opposite of subtraction is addition. But remember that addition is not always adding. This cancels, negative 6 and positive 6 cancel each other. And so x equals, if we have signs that are different, we subtract and leave the greater sign. So 6 minus 4 is 2. And the greater sign is positive, so it's x equals positive 2. For the checkup test, again, we cannot go all the way to the very top, but we can create a checkup test to make sure that we are correct. So we put 4x minus 6 is 2 minus 6. Is it equal to 1 over 4 to the fourth power? In here we have 4. 2 minus 6 is negative 4 because remember, different signs, we subtract. 6 minus 2 is 4 and leave the greater sign, which is the 6, so it's negative. We bring this down, 1 over 4 to the fourth power. And then remember that when we have a negative exponent, we send it to the denominator. Okay, to the denominator, so it's 4 to make it positive. And we just put a 1 on top in the numerator. So 1 over 4 to the fourth power equals over 4 to the fourth power. Okay, so we say check. Let's do one last one. Again, we have 5 and 1 over 125. Again, because it's a fraction, we know that it's going to be a negative exponent. But before we do that, this needs to be factored. 125. We're going to use the smaller base as one of the factors and divide. 125 divided by 5 is 25. And then 5 times 5 is 25. Okay, so how many do we have? Oh, it's 5 to the third power. We just bring everything down on the left. This becomes 1 over because all we did was make 125 into a power. So 1 over 5 to the third power. Just bring this over or down. Now we need this to be a base, so we need to send it to the numerator, and that makes it negative because right now it's in the denominator. So this should just bring it down. 5 to the power of 6x minus 45 equals, this now becomes 1 times 5 to the negative third. Again, by bringing it over to the numerator, this becomes a negative 3. And we haven't done anything to that, so just bring it over. Now, because it's a power raised to another power, what do we do with the exponents? That's right, we multiply them. Just bring this over. 5 to the power of 6x minus 45. And here we have 5 to the negative times positive is negative. 3 times 3x is 9x. Now that we have the same base, we can create an exponential equation. And that's all we'll be working with. So 6x minus 45 equals negative 9x. What do we cancel? Well, because we don't have a constant in here, it's easier to just cancel this 6 over here. So if we have positive 6x, that means we're adding 6x, so the opposite is to subtract 6x. 6x minus 6x cancels because you get 0x and we don't need to put it. Bring down the negative 45. Make sure that you bring the negative because some people leave it up there and just bring the 45 and that makes it incorrect. In here, same signs we add, different signs we subtract, and leave the greater sign. For addition and subtraction, that's the song that I say. Same signs we add. If they were different signs, we would subtract and leave the greater sign. In here, the greater sign is negative because both are negative. The greater one is negative for sure. And same sign, we add. So 9 plus 6 is 15 and bring the x down. Finally, to leave x by itself, to isolate x, if this is multiplication, the opposite is to divide. Remember, in division, we carry the negative with us, okay? The sign stays the same here, here, and here. Why did we divide on this side? Because what we're trying to do is get rid of the numbers that are on the side of the x, okay? So this cancels. Negative 15 divided by negative 15 is 1, that we don't need to put it. So it's 1x. The 1 is right there, but we don't need it. And then negative divided by negative is positive. 45 divided by 15 is 3. So positive 3. So x equals 3. We will need it for the checkup test. Remember that the checkup test is going to go right here. So we have 5 to the power of 6 times 3 minus 45. And then we say, is it equal to 1 over 5 cubed all to the 3 times x, but we know that x is 3. That's what we found down there, okay? That's where we're replacing the 3 where the x was, here and here. Now, we say 5, and we multiply 3 times 6, or 6 times 3 is 18. 18 minus 45 is negative 27. On the other side, we can make this into 5 to the negative 3. Remember, we're putting it up there to the numerator by sending it to the numerator. If it was positive, then it becomes negative. And then we have 3 times 3 is 9. Bring 5 to the negative 27th power equals. We multiply, and negative times positive, well, bring down the 5, and negative times positive is negative. 3 times 9 is 27. So they are the same, and we say check. That's it for our lesson. If you like the video, please share. Make sure that you give us a thumbs up. You can subscribe around here. This is the link to the entire unit, so you will see the other 5 videos in here. And here you will see the next video. Now you're able to solve exponential equations when the base is a proper fraction. And have fun!